First of all, to introduce myself, my name is Zlatko. I work currently at Bending Spoons. It's an Italian-based company. Basically have quite a lot of applications in the App Store for all kinds of media manipulation and stuff like that. Currently, I work on an application called Light Motion. It's a motion graphics app for, actually it's iPhone. There used to be an iPad, but I think we're not supporting it now. I'm gonna talk about protocol witnesses. So first, another plug. This is actually plug for the guys point 3. This is another resource that one basically to add it to your list. What Monica mentioned about some education resources, this is yet another one. I highly recommend these guys because I actually learned about them, let's say, fairly recently. And they have, first of all, their own architecture that we actually use in our company. And they have other bunch of collections here of videos that cover various topics. One of them is the protocol witnesses here. And I mean, I basically stole all my examples from these guys because now my point is to educate and not to create my own presentation and stuff like that. Okay, I think that's enough for this. So let's start with. I'm gonna zoom in a bit. Yeah, okay. Can you see? Probably, yeah. Okay, so first of all, I'd like to ask who has heard about protocol-oriented programming? Okay, I guess most of you, right? So this is, I guess, something that Apple themselves are pushing, and basically it tells you that before you define anything, let's say like a dependency, first you define a protocol, and then you define some structures, some objects that conform to that protocol. Now, the point of this presentation is to actually tell you that there is another alternative to protocols which is actually more powerful and more composable. And the main point is that this thing that are called actually protocol witnesses, when you define a protocol in Xcode, the compiler itself transforms the protocol into the protocol witness during compile time, and by leveraging this technique instead of actual protocols, you might lose in brevity, but you gain in flexibility, and you gain in composability, let's say mainly. You'll see what I mean in during the presentation. So let's start something simple, like let's say we define a protocol called describable, right? And let's say we have a person with properties, right? And we have some rectangle also with width and height. And we define a person and a square, right? And we'd like to describe them. So we will extend person to be describable, and we will extend rectangle to be describable, right? And if we print them, we expect this to print. I guess live coding never works as expected. Of course, what we defined here, like person name, last name, and the rectangle with width and height. But for example, what if we want to implement another way of describing that particular person or rectangle? Let's say if we try here to uncomment this, and we say extension person describable, we cannot do this because we already conform to describable. So now the compiler will complain, right? So this is one of the major drawbacks of using actual protocols for this. So that's why I have to comment out this code again so that it doesn't complain. And so you can say that if we want to, let's say, describe the person in this way and pretty describe it, let's say, in this format. We can say we will extend the protocol with describe and describe pretty, right? And then let's say that we can extend person to implement describe and describe pretty. But for example, if you have multiple conformances, like you have extension of UI view controller or UI view, let's say, with describable, and we will say var describe blah blah. And you have multiple conformances. You'll have to now implement all of this for all the conformances. And I guess this is another limitation. Like you don't want to do this for every conformance out there. So again, this way of doing things, let's say, it's not optimal. Now, what is the solution? The solution is, of course, protocol witness. There is actually a simple algorithm that you can follow through to transform any protocol into a data type, which is structure in our case. And instead of we saw previously, I'm just gonna copy the protocol describable. I'm confused by, let's say I'm gonna paste it here. So instead of defining the protocol like this, we're defining a structure. And I guess these guys are, follow some kind of naming pattern, like if it's a protocol, it's describable, but if it's a protocol witness, it's describing. And we'll name it describing, of course, and we'll implement the generic. It will be generic over, so whatever is self here in this implementation, we already saw that we need self.name and self.lastname. We will actually define it as a generic, and we will define all required methods that were in the protocols, in the protocol definition. We'll actually define them as closures. So we say this is a variable described, and it's actually a closure with input parameter the actual generic and the output parameter is string. Now you'll see why it's kind of more powerful in this case. Like for example, from this describing structure, we can create multiple instances. Like you can create as many as you like. For example, let's say we name this short witness, and we say this is describing over person, and of course we need to implement the closure. So we will actually paste the same way of describing as we saw before. And I guess this is pretty self-explanatory, right? If we say short witness.describe, you'll see the result. Nothing, out of the ordinary. Now we can define a new witness. Let's say we name this witness pretty witness. And again, we instantiate describing over person, we implement describe, and now, for example, we can say, I want to describe this this person in this way, right? And if we run this over person, now you can see that this actually adds all the formatting and it makes it a little bit better. Not here, of course, but if you print it, it will be. You'll see it a little bit later. Actually, you'll see it now. So for example, let's say we have a function which is called print. Again, it's generic over some type. The tag, let's say it's irrelevant. The value is the type itself, the generic. And the witness that we want to use is describing over A. And we say we print the tag and we invoke witness.describe of that value. Of course, it's important that all of these types match. And in this case, if we invoke print, you'll see that this is the short witness print and this is the pretty witness print. If we use protocols only, how this would be implemented, you'll implement it print. Also, you need to conform it like this. You need to make A describable. And as an input, we take string and the value A. And when you print it, of course, this is the tag is element, and we invoke value.describe. So basically, we're saying here that the A input parameter should conform to describable, and we can do this. But for example, you cannot control the way these things are printed, because you have only one conformance to describe for person, which is, I think it was the short name. Yes, it was the short print format, right? Okay, let's move. So let's fix this a bit. So, or actually, let's improve the ergonomics of the witnesses. For example, we can extend the witness, and we can constrain it where the generic is person. And let's say we can define multiple static variables, like this is short, and we instantiate self, and we say describe, and again this thing, and this is pretty. You saw pretty standard stuff. And for example, now the actual invoke of the print statement becomes also a little bit clearer, because you can say print with the tag debug Peter Griffin using short protocol witness, or the same thing with pretty. And of course, it does that, right? Okay, let's have another example just so that you can see this from another angle. Like, for example, you can say, I'm going to extend describing where my generic is bool. And you can implement short, and it will print out if it's true T, or F if it's false, right? Or pretty print, if it's true, it will print out this fancy cursive text, and also for the false one, right? You can say, I want to implement yet another, which is, I don't know, normal, right? Oops. And this is true, this is false. So I hope that you're starting to get a feel of the power here, but we're not over yet. I think now this should work. Yeah. For example, if we invoke debug true with the short, of course it will print out this T small, and then the true with cursive font. Okay. Is it clear so far? I guess. Now a little bit more, some mind-blowing, because this is actually, these are concepts that come from, let's say, math science and computer science as well. For example, a map is defined like, if you have something over A, and you have a function that goes from A to B, then you can produce something over B. But contramap is, as the name suggests, if you have something over A, but you have a function that produces from B to A, you can produce something over B. So you can implement, you can actually extend the protocol, the witness, with contramap. So basically here you're defining another generic. Keep in mind that we already have the A generic still up there. And as an input, we have a function that goes from B to A, but we want to have an output which is describing over B. So we just return, this is also not even needed. We instantiate describing over B when you, where you need to implement describe, but here as an input goes in B. And you say self, which is describing over A, dot describe, and you need A here, right? Because you're invoking this on self. And how to get A, you need to invoke f of B. So why is this relevant? I'll tell you. Let's say that, for example, you can define what we already defined, the short witness, you can define secure short witness. And let's say when we print out the person, we don't want to print the ID because it's a confidential information, right? I'm gonna, yeah, okay. What we do is a secure short witness is we say on the short witness that we already defined, it's already implemented. We implement the contra map where you get the original person, but you say, I will return you a new person because this one expects it, right? I will give you the name, I will give you the last name, but I won't give you the ID. And here, for example, if you call the already defined print method from before, you'll see that now we're printing Peter Griffin with an ID which is obscured. And the same goes for pretty witness, right? Maybe this is not enough, so we will see another example. For example, you have a purchase. You have an amount and a shipping amount, and you have a discounting witness, which it has one method which is discounted. Of course, the input goes in the generic, output is double. You can also define the output if you like. For example, you can say here output, and this will be the output. But let's say we don't want it. We want to keep things less complex, let's say. And for example, if we implement print discount, it's pretty similar to what previously has. It's generic over A. We have the item, and we have the discount witness, which is discounting over A. And we just get the discount from the witness discounting of item, and we just return this, right? So let's say that, okay, let's say we instantiate a purchase. This purchase costs, let's say, $10, right? Shipping is $1.50. We implement the contra map. Actually, you can use also a pullback. These guys suggest to use pullback because it comes, I guess, from, as I mentioned, from math sciences, and it's a little bit better term than contra map because contra map is, I guess, confusing. So you implement it pretty similarly to what we already saw. For example, we say pullback generic over B. We have a function that goes from B to A, but we want to get a discounting over B. So it's pretty easy because you initialize it with other, and we say self, which is discounted over A, remember, over A. But to get A, we have to apply the function that transforms B. Basically, this is B. I think you can even do it like this. It should work. And for example, if you implement witnesses of discounting, and you can implement as many as you like. Like, for example, this one is 10% off, right? $5 off, or whatever you can imagine, right? But then you want to implement witnesses for purchase. Instead of, again, implementing the same thing here, like you can say, if you implement this for purchase, you can say if this is purchase, so this will be purchase, and you'll have to say purchase.amount. I guess the same thing. But you can do it in another way, basically composability. I think it should be okay. I reverted it, right? Yeah. This was double, right? Double, yeah. Okay. And we'll say something like, we'll implement this with, again, the witness 10% off, but this is discounting over double. Actually, this is discounting over purchase, but we're taking the discounting over double dot the 10% off, which is already implemented for double, right? And we say pullback along the amount. You can actually implement this in another way, like if you say pullback, and this is the function, and this should be purchase, and I return here purchase.amount. So this is using keypads. This is the actual implementation, or actually you can also omit this and you can say $.amount, right? But it's even more, it's even clearer if you use keypads. And you say 10% of shipping is take the discounting over double, the 10% off, but pull it back along the shipping amount. And this should work, hopefully, or not. Am I doing something wrong or not? Keypad. Maybe let me see if I am doing something wrong or not. Yes, okay. So let me, I think it's being printed here. Yeah. So here you can say that, you can see that when you already implemented this for double, you can implement it for all the properties of purchase that are double. I think you can even conform to a numeric, was it, right? And you can then implement this, I guess not for double, because this is not for int. Okay, let's go with double. Okay. Does it become a little bit clearer, the composability of these things? I hope so. Okay. I guess the last thing is, what's the point of this? Like, how do we use it? Use this technique in our day-to-day life? Like, for example, you want to implement a protocol which is downloadable. It has an associated type which is format. And let's say that for that downloadable implementation, when you call download, you want to return the format that you define. Like, for example, I can say something like, I can extend URL to be downloadable, download it to string. So here, when you define it like this, actually it infers the associated type, which is this, right? Type alias. Okay, I'm wrong. So basically, your constant, I guess like this. Yeah, you're saying that your format here will be string, and sure, when you implement this, this will be a download string. But what if you want to implement download of data? Let's say we delete this. Now this should complain, hopefully. Yep. Because you have two conformances, and actually it doesn't know how to infer the format, because you have two download functions with different types. So that's why I'm commenting this out. Now, when you convert it to a data type, you say this is the structure downloading. Again, it will be generic over A, but also it will be generic over format, as I told you before. And you say, when for download for a given type, I want to give me another type that I will tell you later on. We can also, again, define the pullback here. Pretty similar. The only extra stuff is the additional generic that we have here, which is format, but it's pretty similar. You say if it's pullback over B, but I want to use the same format, so I'm returning a downloading over B with the same format, but we still have a function that transforms from B to A. And again, it's pretty simple once you get the hang of these things. And let's say that we have a structure which is phone, which has a simple property year in it, right? Now we can say something like, I will extend downloading, where A is URL and format is decodable. And I can say this is the live implementation of the thing, where let's say in this implementation I will receive the URL for this, because when you saw that when we say that A is URL for download, actually maybe this is not that descriptive. If I say init here, this init should be with download, and then I can implement this, and then I will get the URL in. Doesn't matter, just this is even a shorter version of that. And we get the URL, and let's say here you actually download something using URL session or whatever, right? You download this JSON, and then you create an object out of this JSON, and you're decoding it to a format which is format, which we defined it's decodable, so that's why we can run this, and we return the object. But you can also implement a mock, and for the mock, for unit tests, I can want to return this JSON, or you can even define static var failable mock, and you can return something else if you like. And let's say that, again, we have a function which is a download of this format given the URL. And this is the client, or actually, so we're we don't use the term witness, we use mostly clients. Like, for example, I have a network client, I have a persistence client, and all of this stuff. So here it's named client, and it's still the protocol witness of downloading with a URL and a format that's still generic. And you say, this is the URL, and I'm trying to get the phone, and I invoke download of this URL using the live client. And if you saw here the JSON itself here, it should decode it, and this is the phone, right? But you can do something else, again, with the composing, with pullback. For example, I can say, now I want to extend downloading, but A should be string, because I don't want to create URLs all the time from these URL strings. I don't want to care about that. So what we do here is, if you remember, we needed to have a function from B to A. So in this case, we get a string here in the closure, and we can transform URL from string, of course, right? Which is this one. So I'm force unwrapping it here. You can also use some defaults if you like. That's not the point of this example. And then you can have, for example, a new method which is download of URL string. And let's say I have another phone, and I will invoke download with the URL string, this one. So now I don't even care about these things, and it should work. Yeah. Another pretty simple example, and actually this example is, I guess, the closest to what we have, what we use in our companies to model dependencies. And it's pretty powerful because, for example, let's say we have persistence client, right? And we don't even have generics for this. If you have some strictly defined types, like, for example, I want to load some data from the disk, or I want to save some data from the disk, I don't need to define any generic here. And for load, I don't have any input, it's void, and it returns an optional data. For save, I provide the data, and then maybe the client can tell me, yeah, this succeeded or not. And then we say, this is the live implementation of the persistence client. And we can say, for load, this is actual load, and then we return the data of the actual load. For save, again, actual save, and then we say, this is the save successful or not, so we can return whatever, true or false, right? And we can define various mocks. Like, for example, let's say this is a successful mock. And for load, you can say, this is the data, save is true. But failure mock might return nil or false. Or even if these things you define. So here currently I'm defining them as constants, but you can define them as variables. And for example, when you have a variable, you can instantiate this witness, but then on the fly you can override some methods, like the point free guys that I mentioned. They have actually some additional utilities, like it's called unimplemented. And what you okay, and this is self, right? And for I'm gonna just copy this. And for load, I think it, so I don't have the actual library as a dependency, but you say xc test or unimplemented. And I think there is, let's say, you need to provide persistence client.load. And what this will do is, for example, if you instantiate this client, I guess you need to do the same thing here. Doesn't matter. I'm not even compiling this. So what you can do is, for example, if you invoke this in unit tests, let's say that for some particular unit test, you only want to call load. You don't want to call save. So you'll say for load, I will return the data. But for save, if this is invoked during that unit test, it will fail the test. So this is how, for example, you can, let's say that this client has multiple things that it needs to do, not only load and save, but some other stuff. You can say, start with an unimplemented client here, but you can say for, actually, you always start with an unimplemented, and let's say persistence client.unimplemented. Okay, and we say unimplemented.load equals, and this is the closure. And let's say we return nil, right? But in this unit test, if you, for some reason, accidentally invoke save, it will fail. It will only succeed, of course, because you are overriding the load method here. So this is the biggest use case that we use them in our company, of course. I think I'm done. Do you have questions?